Good evening, I am Tomas Guevara, and this is the channel Rewriting the Reality. Subscribe to this channel today to be aware of new developments in quantum physics. In today's episode number 154, I am going to inform you about the Higgs field, which I identify as the regional area number 1 of the universal consciousness, and the tachyon field, which is a new theory. But first, let's see how the quantum physics emerged in the early 20th century as scientists sought to explain phenomena that classical physics couldn't. Here's a brief overview of its development. Key milestones. 1. Blackbody radiation. 1900, Max Planck introduced the idea that energy is quantized to explain blackbody radiation, leading to the concept of the quantum. 2. Photoelectric effect. 1905, Albert Einstein expanded on Planck's work, proposing that light consists of quanta, photons, to explain the photoelectric effect, where light ejects electrons from a material. 3. Atomic structure. 1913, Niels Bohr developed a model of the atom where electrons occupy quantized energy levels, explaining atomic spectra. 4. Wave-particle duality. 1924, Louis de Broglie proposed that particles, like electrons, have wave-like properties, leading to the concept of wave-particle duality. My first comment: this duality explains how the perception's mechanism works, that until today the science community has ignored. 5. Heisenberg's uncertainty principle. 1927, Werner Heisenberg formulated the uncertainty principle, stating that certain pairs of properties, like position and momentum, cannot be simultaneously measured with arbitrary precision. 6. Schrödinger's wave equation. 1926, Erwin Schrödinger developed a wave equation that describes how the quantum state of a physical system changes over time. My second comment is that no system is closed. These discoveries collectively formed the foundation of quantum mechanics, revolutionizing our understanding of the microscopic world and leading to numerous technological advancements, including semiconductors, lasers, and quantum computing. Recently I read an article that said that a straightforward math tweak could bring tachyon fields into line with the rest of physics. Tachyons are faster than light particles, and tachyon fields are special cases of quantum field. The math adjustment enlarges a tiny Hilbert space, which is a fundamental concept in mathematics and physics, particularly in quantum mechanics and functional analysis, into a larger one to accommodate variables. In a fascinating twist of theoretical physics, scientists may have calculated how an elusive particle, the tachyon, could exist without breaking the laws of general relativity. The tachyon field and the Higgs field are both concepts in quantum field theory, but they have distinct roles and properties. Tachyon fields are characterized by having an imaginary mass. This means that their mass squared term is negative, leading to instability in the field. The presence of a tachyonic field indicates that the system is in an unstable state. This instability causes the field to spontaneously decay to a stable state, a process known as tachyon condensation. Tachyons are hypothetical particles that would move faster than light. However, in modern physics, tachyonic fields do not imply faster than light particles but rather an unstable field configuration. My first comment: I have said that we are always inventing particles and then these particles are later confirmed, which validates the uses of our perception mechanism, since we have at our disposition an infinite number of links of consciousness and infinite energy to do whatever we want. The Higgs field is crucial in the standard model of particle physics for explaining how particles acquire mass. It interacts with particles like the W and Z bosons, giving them mass through the Higgs mechanism, which is probably the beginning to recognize our perception's mechanism. At high temperatures, the Higgs field is in a symmetric state. As the universe cools, the field undergoes spontaneous symmetry breaking, leading to a non-zero vacuum expectation value. This process gives mass to particles. Unlike the hypothetical tachyon field, the Higgs field has been confirmed experimentally with the discovery of the Higgs boson at CERN in 2012, which some people call the God's particle. In summary, while both fields involve concepts of mass and instability, the tachyon field is associated with hypothetical faster-than-light particles and field instability, whereas the Higgs field is a well-established part of the Standard Model that explains how particles gain mass. The Higgs mechanism is a fundamental process in particle physics that explains how particles acquire mass. Here's a breakdown of how it works. The Higgs mechanism involves a field called the Higgs field, which permeates all of space. This field has a non-zero value even in its lowest energy state, vacuum state. It's what I called the regional area number 1 of the universal consciousness. At high energy, the Higgs field is symmetric. As the universe cools, this symmetry breaks spontaneously, causing the Higgs field to settle into a non-zero value. The Higgs mechanism involves a field called the Higgs field, which permeates all of space. This field has a non-zero value even in its lowest energy state, vacuum state. It's what I called the regional area number 1 of the universal consciousness. Particles interact with the Higgs field. The strength of their interaction determines their mass. Particles that interact strongly with the Higgs field gain more mass, while those that interact weakly gain less mass. Here I want to comment that we direct these particles in their interaction. They don't do it by themselves because they don't have a mind of their own. How it works. In the Standard Model, the W and Z bosons, which mediate the weak force, acquire mass through their interaction with the Higgs field. Without this mechanism, these bosons would be massless, which contradicts experimental observations. My comment is that in these experimental observations our perception's mechanism plays the most important role. The Higgs mechanism also predicts the existence of a new particle, the Higgs boson, which was discovered in 2012 at CERN's Large Hadron Collider, and has been called the God's particle. The Higgs mechanism is crucial because it provides a consistent way to explain how particles get their mass without violating the principles of gauge symmetry, which are fundamental to the Standard Model of particle physics. Theoretical physicists live in a world the rest of us can't really understand. They identify phenomena from the far-out cosmos, including things that don't make sense to our Earth-centric mindset. Then they flesh out a model using all the things we can roughly calculate. A tachyon is a particle that travels faster than light, superluminal, which is considered impossible. And a tachyon field, therefore, is something that doesn't fit into our current understanding. Tachyon fields have long been the enfant terrible of physics, the scientists explain, but recent work has continued to move them from outlandish toward, maybe, merely implausible. Now, this team is adding another update to keep moving tachyon fields toward plausibility. Their work appears in the peer-reviewed American Physical Society journal Physical Review D. The key, they explain, is in doubling one of the parameters in today's understanding of tachyon fields. The Hilbert space is a working model used in complex mathematics. When describing quantum fields in general, a Hilbert space model with just one particle is enough. In fact, it constrains the math in a way that makes the whole calculation work, because the one particle is never subtracted from or added to. But for tachyon fields, the math is different and must be represented by two intersecting fields instead of one field of just one particle, the scientists say. That's because Hilbert space that depicts a tachyon field has to have enough room for a tricky mathematical switch. In our understanding of working spacetime, there's a series of calculations, the Lorentz transformations, that need to be possible for a particular idea to be plausible. Think of it like any other set of qualifications. If you want to apply to be part of a list of squares, you must have exactly 4 sides of equal length and exactly 4 right angles. Without those qualifications, you're simply in another kind of shape. To be plausible in our world, you must be Lorentz compliant, with the equivalent of 4 sides and 4 right angles. If the tachyon field math is constrained to a Hilbert space of just one side, or input, then the Lorentz transformations don't have room to fully express. That's because in the course of these transformations, the input and output fields can switch and create an outcome that doesn't fit into the Hilbert space anymore. The right space, the scientists explain, must be paired with all inputs and all outputs together. That means they can switch back and forth without moving out of bounds. It's complicated stuff, but so is cosmology. And despite the heady details, what results is simple. This larger Hilbert space removes the 3 largest remaining obstacles in our understanding of tachyon fields as part of the same play space as quantum field theory in general. This, the scientists explain, comes after previous work showing that tachyons are not impossible, but rather more like disturbances of causality. Other scientists have also shown that the math of superluminal particles may not be impossible after all. At one time, physicists were sticking their necks out over the idea of quantum mechanics in the broadest sense. Heck, before that, scientists had to risk their livelihoods to suggest that atoms existed at all, then those subatomic particles existed. Perhaps in years to come we'll all accept tachyon fields as a building block of our world, with fine-tuned detectors for those as well as dark matter and the other theoretical materials around us. All it takes is a slightly larger working space. Finally, let me tell you that any theory is first a belief, then the expert starts using mathematical equations to give these beliefs some more solidity. Sometimes it works, sometimes it doesn't. Don't forget to subscribe to this channel and remember that if you want more information, you can buy my books at Amazon.com.